All right, welcome back, chemistry kids. More on solutions. Now we're getting into actually looking at solubility curves. Okay, solubility curves. This is an example of a solubility curve. It looks very, very busy, lots of things going on. But what it's telling you is lots of different things. It's telling you have different compounds here. Each line represents a different compound. And these compounds, that line is called the saturation line. In other words, that's the maximum you can dissolve in 100 grams of water at a given temperature. All right, so obviously as most of the trends go, as you increase your temperature, you can increase how much you dissolve. All right, there's a couple that don't, and those are usually gases. Gases usually operate of what liquids do. All right, so the line represents the saturation point. Okay, the saturation point at that given temperature. Okay, so whatever the temperature is, whatever temperature you're looking at, say 190, whatever the case may be, that line is the saturation point. Above the line, if I dissolve more than, say, if I'm looking at this KNO3 line right here, all right, this KNO3 line, let's say if I dissolve more than that, I'm way up here, that would be a supersaturated solution. Supersaturated, whoa, I spelled that one wrong. Supersaturated, I didn't spell that right. Okay, supersaturated solution. So a supersaturated solution means that you dissolved more than what you should at that given temperature because of some special techniques you did. All right, and we'll probably make a supersaturated solution in class too. All right, and then if I do say a combination of, say, let's say I have to look at this KNO3 line and say at 50 degrees, let's say I dissolved 100 grams, so I'm above that line, that means it's supersaturated. But let's say I dissolved 85, that'd be right on the line, so it'd be a saturated solution. And then let's say if I actually dissolve 50 grams at 50 degrees, well, that's below the KNO3 line, that makes it a unsaturated solution. All right, so above the line means supersaturated, on the line means saturated, under the line means unsaturated solution. All right, and that's just by looking at those are just things you can specifically tell right away. Generally, as you increase your temperature, the amount you can dissolve increases, but that has to do for solids. But then for gases, if you notice gases like right here, HCl, NH3, SO2, those would be an example of gases. As temperature increases, their solubility actually decreases. All right. So liquids behave a little differently than gases when you're talking about solubility. A calculation you would get from this graph, you have to do an equality. All right. So in this case, how much SO2 can dissolve at 80 grams of water? Let's say at 50 degrees Celsius. The power went out. Okay, well that was interesting. The power just went out. It's cool. So here's how it works out. You look at this graph. I'm figuring this stuff out. We're looking at the SO2. So let's look at SO2 here. Okay, here's the line for SO2. So at 50 degrees, go here. I know that I can dissolve, what is that? About 5 grams. So I can dissolve about 5 grams in 100 grams of water because this graph is set to 100 grams of water. All right, now it's asking how much can I dissolve in 80 grams of water. So I need to find, so here's the equality I just figured out. I know I can dissolve 5 in 100 grams. How much can I dissolve in 80 grams? So I'll just do a little cross multiplying. So 80 times 5, that'd be 400. 400 divided by 100, that would obviously be 4. So I can dissolve 4 grams of SO2 at 50 degrees. Okay. So you can set up a proportion to figure out how much you can dissolve in various amounts of water, and that should also hold true. So looking at solubility curves, you get some ideas of how much you can dissolve of different compounds in different amounts of water at different temperatures. All right, you just got to know what it says to be able to read it. So hopefully this helps with solubility curves. We will talk to you in a little bit.